All right, take it away, Hayes.
All right, thank you.
Good morning. My name is Alex Aldrich.
I'm Jeannie Key.
And I'm Caitlin Supis.
We are all seniors currently attending Hayes High. Our topic is radiation and how it affects cancer. Radiation is energy or particles that can travel through space or a material like cells in the human body. Ionizing radiation is used in medicine to eliminate uncontrolled masses of cells called tumors in the body because it has enough energy to ionize atoms and break chemical bonds. This type of radiation is used to treat cancer because it damages the DNA of cancer cells and they die. We researched the most common types of ionizing radiation used to treat cancer, how radiation is delivered to tissues in the body, and the overall effect that it has on both healthy and cancerous cells.
There are several forms of ionizing radiation used to treat cancer. All work by damaging the DNA of cancer cells, leading to their death. Ionizing radiation can be placed into two categories. Photon radiation, which involves X-rays or gamma rays. These forms of high energy waves will travel through both cancer cells and through the body through healthy cells. Particle radiation emits types of particles such as electrons, protons, and beta particles. This type of radiation typically doesn't travel as far and may be a better option in limiting damage to tissues outside the tumor, especially if the tumor is located in the spine, brain, or near vital organs such as the heart.
There are two types of radiation therapy used in the treatment of cancer. External beam radiation therapy, usually involving a machine called a linear accelerator that directs high-energy X-rays or electron beams from many angles around the body to the specific cancer area. This treatment takes 10 to 30 minutes and is often administered several days in a row. Treatments may continue for 2 to 10 weeks. A second type of therapy is internal beam radiation therapy. It is given through small radioactive pellets that are placed inside the body near the cancerous area. These pellets may be inserted by tiny tubes during surgery, and they deliver high doses of radiation directly to the tumor. Determining the type of radiation needed depends on many different variables that are evaluated by the medical professional team.
Possible side effects of radiation therapy ranging from mild to severe depend on several different factors, such as the type of radiation or the dosage. Certain factors, such as the patient's age and weight, can also affect the amount of radiation the patient can receive. As an example, radiotherapy using cobalt-60 emits gamma rays. Exposure to cobalt-60 treatment can cause skin burns, acute radiation sickness, or death. Radiation treatment is the main treatment for brain cancer. Using either external or internal treatment to target the tumor, radiation will shrink the cancerous cells in the brain. This allows neurosurgeons to be able to remove the tumor from the brain without damaging the remainder of the healthy tissue during mid-process. Along with surgery, radiation is also used with chemotherapy to treat certain brain cancers. Shrinking the tumor is not the only reason radiation oncologists would use radiation on a brain cancer patient. It also helps relieve the symptoms caused by the brain tumor. One major effect is radiation necrosis. This is just another word for dead brain tissue, whether it's healthy or cancerous. Radiation necrosis usually occurs after cancer treatment has ended, and more recent studies have shown that it is irreversible and very difficult to treat, although surgery can be done depending on the patient.
So to give you a better idea of the relationship between cancer and radiation therapy, we would like you to imagine this scenario. We have a 36-year-old female patient with seizures, muscle weakness, impaired speech, and memory loss. Immediately, we ran tests. The following are her MRI scans. As you can see from the scan, the patient has a glioblastoma in her left frontal lobe. Glioblastoma is an aggressive type of cancer that forms from special cells of white matter. In order to better visualize the location of the tumor, we borrowed a preserved left sagittal section of a human brain from the Fort Hays State University Biology Department. At this moment, if you could double click on Alex's screen, it should enlarge her video. She is currently pointing at the location of the tumor described in our scenario. Based on the size and location of the tumor, we would proceed with the following treatment plan. We will proceed with surgery to reduce the size of the tumor to the best of our capabilities. Then, post-operation treatment may also include steroids to reduce brain swelling, daily radiation treatment, and oral chemotherapy for approximately 6 weeks. After treatment, the best outcome for this patient is an extended life expectancy of approximately 3 to 5 years. With no treatment at all, the average life expectancy is up to 1 year.
Over 1 million people are diagnosed each year with cancer in the United States. Continuing research and advancements made in the treatment of cancer, including new therapies and radiation, will hopefully be able to save more lives. Thank you for taking the time to listen to how radiation affects cancer. We hope you found our presentation informative, and we are happy to answer any questions at this time.
Thank you, Hayes. Great job. Let's see, for the first question, what was the most surprising or interesting fact that you learned about radiation treatment?
During radiation treatment, I found it most interesting that that there's two different types, and you can use either internally or externally. And we found out that with internal treatment, radiation treatment, that it actually, like, you can inject it. So if you have a tumor that's deeper in the brain tissue, you would most likely use internal beam treatment to like specifically target that area. And then for external treatment, you would be able to hit a tumor that is not as deep in your body.
Personally, for me, it was just finding out how much math goes into calculating the amount of radiation, the dosage, and it just really brought to light the amount of work that doctors and neurologists and radiation specialists put into each and every day that they go to work. And that just really surprised me.
What I found fascinating about radiation is during external beam radiation, where they use the linear accelerator, you use a mask called a thermoplastic mask, and it's made out of plastic, and you put it in hot water, and they form it to your face, and this helps keep the patient in the precise position to ensure accuracy and the radiation beam to make sure it goes in the right place.
Thank you. Your second question, in your research, what was the overall success rate for radiation to shrink a tumor?
There are actually over 15 million survivors in the US, according to 2019 results.
It depends on the type of tumor, the location and everything. But if you have a great specialist, and sometimes it depends on who the patient is and what they're like, and then the treatment is based off that. And success rates vary from the type of cancer.
Yeah, and it depends on how far the cancer has come and how long you've waited to treat it.
Thank you. And then I also have a question of how does radiation affect different people? Like, does it differ by your ethnicity?
It doesn't affect with ethnicity, but the person's age and weight can also apply a great amount of effect on it, because if a person is considered overweight, the radiation will obviously be harder on their body and it will cause more side effects, and also on their age, because if they're older or younger, depending on the type of cancer, each person will be different depending on their age and how they will react to it.
And depending on their past medical history, if they've had certain things happen to them in the past, then it would be very different.
Just to reiterate on what Kayla and Alex said, everyone has a different immune system. Everyone's bodies are different. So it just depends on how they would react to it.
Perfect. Judges, any other questions? All right, seeing none, we will go ahead and move on. Thank you, Hayes, for a great presentation.
Thank you.
Thank you.
Hi, I'm Ashlyn Harborn.
I'm Zoe Yerke.
And I'm Ruth Williams. And we're going to be talking about the cancers of the immune system, their symptoms, treatments, and their success rates. And we are from Great Bend High School.
There are two cancers of the immune system, leukemias and lymphomas. Leukemia is a cancer of the blood-forming tissues, and it prohibits the body's ability to fight infection. There are four main types of leukemias. Acute myeloid is where the bone marrow cells cannot mature, so there is an excess amount of immature white blood cells. Chronic myeloid starts in the certain blood-forming cells of the bone marrow, and it is caused by a chromosome mutation that occurs spontaneously. Acute lymphocytic is in the blood and bone marrow, and it affects the white blood cells, and it occurs when a marrow cell develops errors in its DNA. Chronic lymphocytic is a cancer of the blood and bone marrow, and it envelops from a type of white blood cells called B cells, and it progresses slowly and mainly affects older adults. Lymphomas are a cancer of the lymphatic system, which is the body's disease-fighting network, so it affects the immune system. There are two types, non-Hodgkin's and Hodgkin lymphomas. Non-Hodgkin's consists of B lymphocytes and T lymphocytes, and Hodgkin lymphomas include classic Hodgkin lymphomas and nodular lymphocytic predominant Hodgkin lymphomas. But today we are going to be focusing mainly on leukemias. Leukemia involves the white blood cells. Your white blood cells are the main infection fighters in your body. They normally grow and divide in an orderly way when needed, but when a person has leukemia, the bone marrow produces abnormal white blood cells that do not function properly. The more abnormal white blood cells that are produced, the less there are of healthy white blood cells, which can properly fight infections.
So some of the first early signs of leukemia include no appetite, which can lead to weight loss, tiredness, night sweats, and fever. And it's hard to determine that this is leukemia from these early symptoms because these symptoms are also symptoms of some less severe sicknesses, such as influenza. But if your blood does not get enough healthy red blood cells, then you experience pale skin, irregular heartbeat, dizziness, and shortness of breath. And this is because your body is not getting enough of the oxygen that it needs, because red blood cells provide that oxygen to your body. If your body doesn't have enough healthy white blood cells, then you get achy muscles, fatigue, and diarrhea. And this is because your body does not have enough of the cells that are fighting infection and helping you get through those little hiccups of the day, and they just help you get through the day. And then if your body does not have enough healthy platelets in the blood, then you experience bruising, bleeding that won't stop, small red spots under the skin, and sores that won't heal. And this is because platelets cause clots in the blood and help your body heal. And so if you don't have those, then you'll experience those symptoms.
There are many treatments for leukemia. Chemotherapy is a major form of leukemia treatment, and it is a drug treatment that uses chemicals to kill the leukemia cells. It can be in pill form or it can be directly injected into a vein. Biological therapy uses treatments that help the immune system recognize and attack leukemia cells. Radiation therapy uses X-rays and other high-energy beams to damage leukemia cells and stop their growth. Stem cell transplant replaces the diseased bone marrow with healthy bone marrow. There is a 61.4% 5-year survival rate for leukemia. So the picture of the little girl you see on the slide is actually a picture of me when I was 2. I didn't have leukemia, but I had a neuroendocrine tumor that was wrapped around my pancreas and adrenal glands. I'm going to talk about some of the side effects I still have today. So I have the possibility of being infertile due to the oocytes since they're rapidly growing to cells, and chemotherapy targets rapidly growing cells, so that could have killed them off. And another reason why I might be infertile is because the type of cancer I had released a ton of estrogen, and I had my period when I was 2, along with all the things that come with your period. Another side effect I have today is that I have to get my ears checked quite often because the chemotherapy can affect the fine nerve endings inside your ear. Another one is that my teeth are very weak and I've had multiple dental work done on them because the chemotherapy stopped my teeth from developing in the properly way from when I was younger. And so I also have weak enamel, so I'm more prone to cavities. There's new researchers are trying to come up with new interventions all the time. So it doesn't just target the whole body, it targets certain spots. Enasidenib targets a specific gene mutation called IDH2, which prevents your bone marrow from having your young blood cells develop into healthy adult blood cells, which can result in AML. To detect if a person can benefit from this drug, in real-time IDH2 assay can be performed. It's a PCR assay for qualitative detections for the mutation. Another drug is the liposomal cytarabine daunorubicin CPX351. And it's a 2-drug chemotherapy rationally designed to improve the efficacy over traditional AML treatments.
Thank you for listening to our presentation about cancers of the immune system and our focus on leukemia. And we'll take questions whenever.
Thank you, Grant Bend. Just waiting for the questions to come in. Just one second.
Should I exit?
Exit the slide.
All right, first question. What is the most important message you want the audience to take away about this topic?
Do you want to answer first?
Yeah, go ahead.
Okay, so the most important message I want people to take away from this is the different types of leukemias. When people talk about, oh, I had leukemia, there's actually multiple forms of that. And most people don't realize how many types of leukemias there are.
I think it's important to realize that like there is a 61.4 5-year survival rate. It can be beat. It's not the end of the world. I mean, it's definitely a struggle, but I believe that if you push hard, you get through it, and that we all need to help bring other people up and just help others get through it when they are sick with something like this.
I think an important message is to be aware of the symptoms because, like Ruth stated earlier, the early symptoms can be like mixed with other things other than leukemia. And so recognizing those symptoms could help with an early diagnosis.
Thank you. Next question. What are the causes of leukemia? Did you find anything like regarding smoking, genetics, etc.? And did you find any statistics concerning acute leukemia and how many people it affects, such as does it affect more men than women or vice versa?
The genetics part, as I stated, the enasidenib, like that, the new drug, there is the gene mutation that's the IDH2, which prevents your bone marrow from having your young blood cells adult into healthy adult, or your young blood cells properly develop into healthy adult cells.
We did find that some of the leukemias, such as the chronic lymphocytic, affects older adults rather than younger children, because that's when the white blood cells are not producing or not becoming mature. So it affects older people rather than younger kids.
At this time, I don't think that we have the information for the proper causes, but if you'd like us to do further research and get back to you, we more than likely could.
Okay, thank you. The last question, which you kind of touched on this already, but in your research, were you able to find like an average age of diagnosis for leukemia? And then what was the most interesting thing that you learned while doing your research?
I don't know if we had an average age. I don't believe we've had an average age. Like I said, it just can affect older adults for the chronic leukemia, but we didn't find or didn't look into an average age for that. Personally, the most interesting thing for me was a bunch of different types of symptoms and how the lack of specific things in your blood can cause a bunch of different symptoms. And I thought that was interesting.
The most interesting thing for me was the different treatments that can help with it, because it depends on like what type you have, obviously, and how severe and stuff. And so there's multiple treatments that can help you get through each stage of that. The most interesting part for me is all the new interventions that researchers are trying to come up with to help improve the later side effects and everything.
All right, any more questions from our judges? All right, seeing none, that will conclude our presentation. Great job, great bid.
Hi everyone, welcome to our 2020 K Unite the Lab presentation. We are Easton King,
Hannah Eckstein,
and Riley Johnson from Frontenac High School. Today we will be answering the following questions. What is leukemia? What are the symptoms, treatments, and survival rates? We will also be addressing prevention and how you can help leukemia patients.
First, let's get started with what leukemia is. Leukemia is a cancer that affects the blood cells and bone marrow.
Unfortunately, the exact causes of leukemia are unknown. However, scientists do have a few ideas as to what those causes potentially could be, such as previous chemotherapy, exposure to cancer-causing agents, and genetic conditions.
Leukemia can be acute, meaning the cancer progresses quickly, or chronic. The cells grow too fast or too slow. Also, depending on the type of leukemia, different cells are affected. Either myeloid cells, as known as bone marrow, or lymphoid cells, immature white blood cells.
On the bright side, leukemia research is always in action. We will talk about different treatments later on in the presentation.
Next, let's move on to leukemia types and symptoms. There are 4 main types of leukemia. The names come from how it spreads, acute or chronic, and where it starts, the lymphocytes or myeloid cells.
Now, we're going to give you a scenario. Here are 2 blood samples. At first glance, they look the same, right? But there's something very different about them.
One of these patients is suffering from CLL. Looking at the slide, what are some key aspects of CLL? It's the most common chronic leukemia, and
Here, I'll give you some numbers. Patient A has a white blood cell count of 14,000 per cubic microliter, while patient B has a count of 6,000. That's quite a bit of a disparity, wouldn't you say?
because of the high white blood cell count, it is clear to both us and doctors that patient A is suffering from CLL.
Before we move on, let me introduce you to someone very special. This is Adam. He is a student at our school who is currently suffering from leukemia. And even before COVID, he would have to wear masks to school to protect himself. He has had a deep impact on both our school and our community, and we have had multiple fundraisers to support him. Because of him and his fight, we wear orange.
Also listed on slide 3 are the most common symptoms of leukemia. Most of these symptoms are self-explanatory. Petechiae is when there are red spots visible on the skin. The spleen can become enlarged because it gets swarmed and clogged with abnormal cells, or blood vessels swell too much, causing the spleen to close. Constant infections occur because the immune system is weak and the white blood cell count is low.
One of the biggest keys to beating leukemia is early detection. In this short video, Dr. Monique Sajad from St. Petersburg General Hospital outlines a few key aspects of early detection and symptoms.
So the warning signs of leukemia would be fevers, feeling very weak, noticing that you're bruising easily, or bleeding anywhere. Also, the most common way that they're diagnosed is on routine blood work, having a high white blood cell count.
Here are a few treatments and their survival rates. Of course, we have chemotherapy and radiation therapy, both of which are very common in cancer patients. The treatments we found most interesting were biological therapy and targeted therapy.
First, biological therapy works by using treatments that help boost your immune system to help recognize and attack leukemia cells.
Second, targeted therapy uses drugs that attack specific vulnerabilities within the cancer cells. For example, the drug imatinib attacks a specific protein within chronic myelogenous cancer cells. This can help limit and control the disease.
Another interesting therapy is stem cell transplants. A stem cell transplant is a procedure to replace your diseased bone marrow or blood stem cells with healthy ones. The patient may receive stem cells from a donor, or they may be able to use their own stem cells.
Next, we have the different types of leukemia and their 5-year survival rates. The lowest by far is acute myelogenous leukemia, with only a 28% 5-year survival rate. On a brighter note, the survival rates have been steadily increasing over the past decade, which is promising for patients everywhere.
I hope through this presentation, you all have learned a lot about leukemia, and you may be asking how you can help these patients. Here are a few organizations and how you can support them.
We have the Leukemia and Lymphoma Society, where their tagline is "Beating Cancer is in Our Blood," and the Leukemia Research Foundation, who is dedicated to conquering all blood cancers, including leukemia.
Additionally, we have Be the Match, sponsored by the National Marrow Donor Program. Through Be the Match, you can register as a donor and potentially be matched with a leukemia patient. Quite actually, your bone marrow and blood stem cells are the cure for so many patients.
It is so easy to register to be the match. All you have to do is go to their website, enter some information about yourself, and they will send you a testing kit that's like this. Once you get this testing kit, all you have to do is swab the inside of your mouth and send it back to be the match. Your name and information will then be added to a database where you could be matched with a patient in need. We here today are taking the pledge to register for Be the Match so that we can help be a part of the cure. I encourage you to join us in pledging today and register for Be the Match so you can save a life.
The question remains, how can you help? We have a few ways, from donating financially or physically to educating others. There are so many ways for you to help leukemia patients.
With that, we conclude our presentation, and I hope you have enjoyed our time here with us. If you're interested, please read our citations on our reference slide. A special thank you to the Adam Lamb family, Julie Munkin, our advisor, the University of Kansas Medical Center Area Health Education Center, and you for watching and judging us. We hope you all have enjoyed this presentation and have an amazing day. Now, Seth, if you could please give us any questions the judges have.
Thank you guys for that presentation. Our first question: what is the most important message that you want the audience to take away about this topic?
The most important message we have for everyone here today is that you can be a part of the cure. We know that leukemia can be stopped. We know how to prevent and end this disease. And if we would all just register to be a donor, then we would be able to help patients all over the United States, especially for those of us who are of minority skin tones. We would then be able to have a greater diversity within this registry. Right now, the patients suffering from leukemia who are Black or Indigenous or Asian do not have as much of a representation within the registry and therefore can't get as much help. So if you could please, please, please register and be a part of the cure, that would be amazing.
Great. Second question. Did your group happen to interview Adam, and how has leukemia personally affected him and his family?
So we got in touch with his mom, and we weren't able to Zoom with him, or else we would have, but she did say we could use his name and his picture in our presentation. But we do know how much it has affected him. We had to make a bunch of t-shirts just to raise some money for him.
His treatments, as you all know, healthcare is very expensive. So for our school to help out with that, we made these t-shirts saying "Cancer Picked the Wrong Kid" so that we could support him and his family. And there are also multiple GoFundMes if you too would like to support Adam.
Thank you. The last question for you is, you mentioned that AML has a low survival rate. Is AML more rare than the other types of leukemia? And if not, what did you find in your research about the most rare leukemia type?
AML is one of the most rare leukemia types. There is a fifth leukemia type that we didn't address here that is also very uncommon within patients because it usually starts as this type of leukemia and then transfers into AML. And because AML is so rare, it doesn't have a lot of strong treatment options. Additionally, the way it spreads is very difficult to attack quickly enough that we could prevent the end result of death. Any other questions?
Do our judges have any further questions? All right, I'm not seeing any front neck. Great job. Thank you.
Thank you.
Hi, my name is Nipa Marval.
And my name is Daria Mohammedzadeh, and we are from Olathe North High School.
Today we will be presenting the types of gynecological cancers, as well as their symptoms, treatments, and survival rates through a short skit. To assist us with this skit, we have Mrs. Rhonda Rice, a survivor of ovarian cancer herself. This is a little overview of what we will be going over, and let's get started. Hi, ma'am. What brings you in today?
Well, doctors, I recently got a genetic test to see what cancers I could potentially get, and my results confirmed that I have a genetic mutation on breast cancer gene 1. And I researched a bit and found out that this could also cause ovarian cancer, and my family has a history of that. So I was wondering if I could get some basic information about these cancers and ovarian cancer itself.
Yes, of course. So let's start by talking a bit about cancer. Cancer is a malicious disease which is caused by the rapid and uncontrollable replication of cells. These cells eventually invade nearby tissue and spread throughout the body. The mass production of cancerous cells deprive regular cells of important nutrients that would help them potentially fight off disease, making the body weaker and more prone to illness.
And in this diagram, you can see the 5 areas where women are most commonly affected with gynecological cancers in the United States. Now, the 5 main types of gynecological cancers are individual and unique in themselves, but 4 out of the 5 cancers, cervical, uterine, vaginal, and vulvar, can be caused by HPV, old age, and smoking. While ovarian cancer's causation is more dependent on genetic mutations, specifically in breast cancer gene 1 and 2, which is the one that you have.
Well, what symptoms or what signs should I be looking for?
So ovarian cancer can exhibit abnormal vaginal bleeding or discharge, as well as feeling full too quickly or difficulty eating, pelvic pain or pressure, a more frequent urge to urinate, or having constipation, bloating, and back pain. And because ovarian cancer has symptoms that are similar to other cancers, we compiled this chart so that you could distinguish between the symptoms of the other gynecological cancers.
And as soon as you think you're experiencing any of these symptoms, it's important to come visit us as soon as possible because early detection of cancer can lead to higher survival rates. It's really good that you got a genetic test done because it's an efficient way for early prediction and detection of cancer, which will help our team and you be ready to combat this cancer. Now, as you come to the clinic, we would do some tests on you to properly diagnose. Usually, we would do a physical exam where we would feel for any abnormalities and look for discoloration. But because this is most probably ovarian cancer, we would try to use other testing mechanisms. We may do some laboratory testing where we would collect your blood and urine samples to look for any irregularities caused by disease. We may also use scanning tests such as MRIs, CTs, and PET scans to non-invasively examine you. If non-invasive techniques aren't giving us proper results, we may have to perform a biopsy where we would enter your body surgically to collect samples of cancerous cells. Once we have completed the diagnosis, we can look at potential treatment options. So we could use a drug-based pathway involving chemotherapy or targeted drug therapy, or we may approach a more manual pathway where we would remove the cancer surgically. And a last option could be radiation therapy, where we would use high-energy particles or waves to help destroy this cancer.
Okay, well, what are the survival rates for these sorts of cancers?
Right. So when it comes to statistics for survival rates, many researchers use the 5-year relative survival rate method. The data presented here shows the chances of the patient has of surviving 5 years after detection. The data on the chart shows the average survival rate for each cancer, and this mean is derived from averaging the statistics of different characterizations of the cancers, and the 3 types of characterizations being localized, regional, and distant cancers, describing how far the cancer has spread. The more it has spread, the less chance of survival would be. It is important to consider that these rates are from 2019, and with time, we see a vast improvement in treatment options, helping combat cancer in a vigorous way that would boost survival rates.
And here you can see a timeline of important advancements in research and treatment of gynecological cancer. The gene that you have a mutation on was cloned in 1994, and it opened many opportunities for research because of this.
Thank you so much for helping me. This has been very informative.
No problem. For most of our information and statistical research, we use the CDC and the Mayo Clinic. Shockingly, according to Yale Medicine, over 100,000 women experience gynecological cancers in the United States every year.
And instead of doing a typical presentation, we decided to do a small skit to not only provide the crucial information, but to do it in a way where we can raise awareness for gynecological cancers and show what a typical woman in the US experiences. We hope that the research and problems we present today are someday solved by the medical science industry. Thank you so much for your time and this opportunity.
Thank you, Olathe North. Let's see if we have some questions for you. Okay, first, were you surprised by any of the statistics that you learned about gynecological cancers?
Yes, absolutely.
Yeah, Daria and I were discussing this a couple days ago, and it's really shocking that so many women have to go through this every day. And that's why we kind of decided to do a skip method, because we wanted to present what an ordinary woman can go through just because of the possibility of a gynecological cancer.
Thank you. What was the most interesting item that you learned during your research?
For me, it was how prevalent HPV was in causing these gynecological cancers. I mean, it played a role in almost every one of them, and most especially cervical cancer. And that's why it's really important to get an HPV vaccine, which we showed on our timeline when that was created.
And for me, it would probably be about how breast cancer gene 1 and 2 can cause a mutation that can result into this cancer. And it's crazy that this is actually happening on a micro level that is causing this vast cancer.
Thank you. Last question. You mentioned that 4 out of the 5 gynecological cancers can be caused by HPV. So what all did you find in your research about HPV and the importance of the vaccine?
Yeah, so HPV has been found to play a role in these cancers, like in cervical cancer. If it stays in your body and if your immune system cannot overcome it changes your cells in your lining of your cervix, and it makes them become cancerous. And as well with vulvar cancer, it can cause the skin condition vein, which is a risk factor for vulvar cancer. And yeah.
All right. Any other questions from our judges? All right. I am not seeing any. Thank you for a great presentation.
Hello, my name is Connor Cup.
I'm Elizabeth Merle.
I'm Kayla Wynn.
And we're from Garden City High School.
And today we'll be talking about chemotherapy and how it works against cancer.
So what is chemotherapy? Chemotherapy is a method that is used to treat cancer, and it uses drugs to kill cancer cells. It can be administered in 3 different ways. The first is by injection. Now, it can be injected into different parts of the body. The first is intra-arterial, which is into the arteries. Next is intraperitoneal, which is into the peritoneal cavity, which is also known as the abdominal cavity. Next is intrathecal, which is into the spinal canal. Lastly is intravenous, which is into the vein. It can also be administered topically, which is on the skin, and orally, which is through the mouth. So how does chemotherapy work? It targets cells that grow and divide quickly. It doesn't target just one spot, it targets the entire body as a whole. It can affect non-healthy cells as well as healthy cells. It does 4 things. It can cure cancer. It can also control cancer or keep it in one area. It can prepare cancer by shrinking it down in order for it to be surgically removed, and it can ease symptoms.
Moving on to the chemical makeup of chemotherapy. It is difficult to narrow this subject down because each treatment is developed personally for every single patient, which means that the type of drug and also the administration of the drug varies. So because of this, we are just going to go over 2 of the most common drugs and their chemical makeup. First being asparaginase. Its chemical formula is displayed right beside its name. It is a tetrameric protein. It is an enzyme made from the bacteria called E. coli. There are a couple other forms though. One is isolated from the bacteria called Erwinia, which is for people with allergies to E. coli. And the other one is stabilized with a polyethylene glycol coating, which makes it need less doses to be effective. Moving on to the next drug is doxorubicin. Again, its chemical formula is displayed right beside its name. It is an anthracycline antibiotic, and it is made from a natural product produced by the soil fungus Streptomyces. And again, it is also available with the polyethylene glycol coating. Here is a visual representation of doxorubicin's chemical formula. And it goes as follows. Carbon 27, which is the gray spheres, hydrogen 29, which is the white spheres, nitrogen, which is the blue sphere, and oxygen 11, which is the red spheres.
Moving on to how chemotherapy works against cancer. So what exactly are cancer cells? Cancer cells are mutated cells that divide at a quicker rate than healthy cells. And since they don't have the time to mature because they are duplicating and replicating at a fast rate, they result in lumps and tumors that doctors are able to see. So how does chemotherapy fight cancer cells? Chemotherapy drugs can't differentiate between healthy and cancerous cells, and this results in healthy cells being damaged alongside with cancerous cells. And this shows through the various side effects from chemotherapy, such as nausea, vomiting, hair loss, among others. And the chemotherapy drugs are able to target cells at all phases of the cell cycle.
So which chemotherapy is the most effective? We will be talking about 5 different types of chemotherapy. The first is alkylating agents. These damage the cell DNA and keep the cell from reproducing. This works for brain, lung, breast, ovarian cancers, leukemia, lymphoma, Hodgkin's disease, multiple myeloma, and sarcoma. Examples of this would be busulfan, cyclophosphamide, and temozolomide. The next type is anti-metabolites. These act as a substitute for DNA and RNA when the DNA cannot replicate because of the cancer. This works for breast, ovarian, and intestinal tract cancers, as well as leukemia. Examples of this would be 5-fluorouracil and 6-mercaptopurine.
Next, we have anti-tumor antibiotics. It damages cells at all stages of the cell cycle. Examples of this are bleomycin and doxorubicin, and this works for all types of cancers.
The fourth type of chemotherapy are topoisomerase inhibitors, and this interferes with enzymes that separate strands of DNA, making it so that DNA is unable to replicate. And this works for lung, ovarian, gastrointestinal cancers, along with leukemia. And some examples of this are etoposide and topotecan. The last type of chemotherapy are the meiotic inhibitors, and this damages cells at all phases of the cell cycle by keeping enzymes from making proteins needed to replicate. And this works for myeloma, lymphomas, leukemia, along with breast and lung cancers. And examples of this are docetaxel, eribulin, paclitaxel with vinblastine.
So these are our sources that we used to research this information.
Thank you for watching. And we are able to answer any questions you may have for us at this time.
Thank you, Garden City. I will wait for questions from the judges. Okay, first one, when did chemotherapy become readily available for cancer patients, and what did you find in your research about how chemotherapy has evolved since its creation?
So while we don't know the exact timeline of chemotherapy, we do know that, it has evolved in the different types that are available and the way it can be administered.
And it also varies with the type of person and what stage they're at in their cancer, along with the type of chemotherapy and how it may react to their body.
And you continue on with what Ellie said, how it developed with more types of chemotherapy. Now we know there are more than 200 different types, and back then there were only a slight few.
Thank you. Second question, what was something that you learned that was surprising regarding chemotherapy?
Yeah, so I found surprising that chemotherapy can be administered topically for skin cancers. I did not know that until I researched it, and I thought that was really interesting.
I thought it was interesting how there are specialized types of chemotherapy to work for different types of cancers. So a type of chemotherapy could use for brain cancer when another type of chemotherapy could use for all types of cancers.
And like I said before, there are over 200 different types, and I did not know that, and I found that really fascinating.
Thank you. Would there be any reason to combine the different types of chemotherapy treatments?
There are, depending on the type of cancers, doctors can use different combinations of chemotherapy for many ways, just to make the dosage higher or make it stronger for the type of chemotherapy and how far along it is in the stages of cancer.
And like if it's in a certain area, if it's in multiple areas of the body, you'll need to use multiple.
Right. And like we said before, it varies per patient. So, you know, one patient may use a few types of chemotherapy and another one could only need one type.
All right. Thank you, Garden City. Appreciate your presentation. All right. So at this time, we are going to go ahead and announce the winner of this year's competition. Before I do, I want to thank you all for participating. I know this takes a lot of work on your part. And again, especially this year, given COVID, you guys had to work and do this through some extreme circumstances. So I commend you for all your hard work and effort put into these presentations. So due to COVID, our plaques have not came in yet. So those will be mailed to everybody this week whenever we get those from the company. Everybody will be receiving state participant certificates showing that you moved on from your regional events to represent your regions at the state competition. Our third place finishers will receive third place certificates. Our second place team will receive a 5x7 KU plaque for their school. And our first place finishers will receive 5x7 plaques for each individual and an 8x10 plaque to showcase in their classroom or trophy case at their school. So at this time, I would like to recognize our third place finishers from Frontenac High School, Hannah, Easton, and Riley. Great job, guys. Our second place finisher this year is Hayes High School, Alex, Jenny, and Caitlin. Great job, guys. And this year's first place KU AHEC Night at the Lab champion goes to Olathe North High School. And I apologize if I butcher the names. Is it Napam and Darya? Congratulations, guys, on a job well done. I'm very proud of all the work that you guys put into this. I hope that you guys will all come back next year and keep competing. It seems like every year our presentations just get better and better.